Hi, my name's Paul. I work for Red Hat, and in this video I'm going to walk you through the cephmetrics project, which provides, like it says on the slide, end-to-end monitoring for your Ceph cluster. So cephmetrics is within the Ceph project on GitHub. There's the link on the slide. So lucky for you, I'm not going to just give you lots and lots of slides. I'm just going to go through a demo. So first things first, we need a Ceph cluster to monitor. So here's the cluster that we're going to be looking at. It's a containerized Ceph environment. So here's one of the hosts. We can see there that we've got the OSDs running as containers. And if we look on this host, we can see mon and manager actually active. So let's have a look and see what the cluster looks like. So we have clusters in a healthy state. There are 99 OSDs. We have 3 mons. We have managers active. We have an MDS. We have RGWs in the picture, as well as TCM runner, aka Icicle active. And we can see at the bottom there we have IO coming against it. So this is just a demo cluster. So what I'm doing is generating noise, just so that we've got some charts to look at, which don't just look like flat lines. So that's the environment we're going to be monitoring. So what does cephmetrics look like? So cephmetrics is built up from a hierarchy of dashboards that sit inside Grafana. And for this particular release that we're sort of aiming for, the data is all sourced through Prometheus, because Ceph Manager has an embedded Prometheus exporter. Cephmetrics as a project also supports older releases of Ceph through Graphite and Collect D, where we put our own Collect D collector on each of the nodes, and that gives us awareness for OSDs, RGWs, basically the same sort of dashboards that you can see right now, and the same hierarchy. But anyway, let's talk about where we are right now with Prometheus side and containers. So we can see here this is at a glance. So the first thing to note is at the top we have some links off to other dashboards. So we have cluster, pools, OSDs, S3, OSD hosts, and network, different views on the data that we're gathering. So they're links off to other dashboards. For the at a glance view, we've got first row is the usual suspects of metrics about how many mons we've got, how many OSDs we've got, etc. On the right hand side, we've got some stuff which might need explaining. So 7-day growth rate and weeks remaining. So 7-day growth rate is basically a delta from the sample time from yesterday compared to the same sample time from 7 days ago. That gives us what the differential is, so what our growth rate is in those 7 days. And then the weeks remaining panel takes that growth rate and says, well, okay, if we're growing at that rate per week, how many weeks have I got, given that I know how much capacity I've got in the cluster? So that's why we've got the weeks remaining, which is huge, because this is just a test cluster. The middle row, when you start looking at performance, we start off with recovery and backfill ops. So if recovery or backfill is active, we'll see that that gauge change. So that could be PG splits going on, disk being added, disk being removed, failures, that kind of stuff is going to show in that panel. And then as we move to the right, we can start seeing client IOPS, client throughput across how many pools. All the IOPS is all Ceph related on this layer. And then rounding it all off, we have a bit of a drill down into what is the read-write ratio of that client IOPS. So this helps us understand what the workload is that we're trying to do, because obviously writes are more expensive than reads. So let's have a look at what the workload actually is that we're seeing. That's what that's for. And then to round off that row, we have the apply and commit latencies. So we can see how well we're actually doing our writes out to the back end. And then the final row is where we pull together the stats from Prometheus node exporter. So we're able to say for OSD hosts, how busy we're making those CPUs, how much RAM we're using across those OSD hosts, how many physical IOPS is my client IOPS changing into. The same goes for throughput. So we can start getting a feel for the actual load that is being seen at the back end. And as well as, IOPS and throughput, we're also showing disk latency. And to round that row off, we can see disk utilization as well. So what we're seeing here is we've got an average of 36%, and at the 95th percentile, we're at 49. So there's not a great deal of variance there. So we've still got work that this cluster could probably handle beyond the 10,000 client IOPS that we've got right there. So that's at a glance. That's where you land when you log in to Grafana. So let's look at what cluster gives us. So it gives us a little bit of the same set of metrics that we saw before, plus some extras. So we see cluster flags. So if you've got no scrub or no out or no down that's been set, then they would show up here, and those boxes would be orange. If we look at cluster capacity, we can see the usual sort of metrics that you want to sort of track: object history, the actual capacity itself over the past 7 days, and by pool. And then finally, again, from a cluster sort of standpoint, we look at the version information. So each one of our daemons has a Ceph version. So this breaks it down into the daemon type. And so we can see, for example, that I've got OSDs here that are running 12.2.5 as well as 12.2.4. So we've got a mix. So that's our clusters. Then if we want to look at pools, so we've seen at a glance that we've got client IOPS. So how do those client IOPS actually break down into the number of pools, those 9 pools that we also showed? So we can see here we've got client IOPS by pool. Hover over it, we can see that RBD is by far, that pool is tracking the bulk of the I/O. Correspondingly, when we look at the throughput by pool, by far the most throughput is going into the RGW buckets data, excuse me, pool, which is what you'd expect, because you've got large IOs in the RGW space, small IOs in the Icicle E workload that I'm generating. Beneath that, we've got top 5s. So you could have many pools within your environment. So what we're focusing on here is just the top 5s to keep an eye on, based on how busy they are from an IOP, a throughput, or a capacity perspective. So that's a quick glance. And then if you wanted to go down to a particular pool and see what's going on, so if we want to look at RBD, every pool is listed here from a performance detail perspective, so we can look at the read-write ratio against the RBD pool and what the read-write throughput is that particular pool is attracting. So I'm running a random read-write 8K 50/50 workload, which is why we're seeing this nice even balance between reads and writes. That's how we talk about pools. Next one up is OSDs. So the first thing you'll see is an overall summary. So we can see that 99 OSDs are all up, and then we get a breakdown of the OSDs to help us identify where they physically are. And then also to help us understand what the OSD is, we've got an OSD type summary. So we've got a breakdown by the device class. So in my environment, I've only got hard disk drive OSDs. So that's why we've got a solid green. If you've got SSDs in the mix that are being used as OSDs, then you'd see that listed there too. In the same vein, we've got OSD size summary. So if you've got mixed media, say 2 and 4 or 8 terabyte drives within your cluster, then that would show up there. In my environment, it's kind of vanilla. Everything is the same size. I took what I was given. And then finally, object store. So I guess the size and object store types and those kind of breakdowns would help with tech refresh. So size would help if you were moving from, say, 2 to 8 terabyte drives. You could track progress there. And also the object types, if you're moving from fast store to blue store, that would be a good visual indicator of how far through that migration you were. So that's at the high level. And then to dive into latencies per OSD, the default is that you get this table which shows who the busiest ones are. So what we can do is look at, and this is just applying commit latency. So this is Ceph's view of the world. In this environment, my OSDs have SSD journals, which is why this is quite quick. If we wanted to zoom into a particular OSD, then we've got this pull down at the top. So we can select, say, OSD2, and then we can see what OSD2 is doing at that point in time. Here's the history over the past period, and we can compare side by side that particular OSD with the 95th percentile of all the OSDs. So you can see whether or not a given OSD is worse performing than the most or better performing than the most. So it's good for diagnostics. So that's that one. So that's what we do for OSDs. The blue store is all empty, no data there, because in this environment I don't have any blue store. Let's moving on to S3. So this is the RGW. So let's look at what that tells us. So we get a breakdown, again at an overview level of requests by RGW, and then we look at what the bandwidth is consumed by gets and puts, so we can see what kind of traffic we're seeing across all of my gateways. And then we get finally this view here, which is the bandwidth by RGW instance. So in this environment, we're seeing pretty much the same even distribution, which is basically the workload generator is doing it that way. And then we get a breakdown by every RGW host. So this is kind of useful if you've got lots of RGWs and load balancer, and maybe your load balancer isn't distributing as well as you should, or as well as it should. So you can see that kind of thing happening in these charts and rectify with a call to your friendly network specialist. So we can see here that we've got a breakdown of gets and puts. We've got a breakdown of the throughput that we're seeing for that particular host. And also another way of looking at it is the pie chart too. So that's a whistle-stop tour of RGW. Now let's look at OSD hosts. So as I mentioned, we're bringing together end-to-end. So this is data from Prometheus's node exporter, which is installed by the Ansible playbook within cephmetrics. So by default, we see all the OSD hosts in this table and how much space they're contributing, how many drives each one of those nodes has. And then if we look at OSD load, we can look at the drive utilization heat map. So the thinking here is that this heat map allows us to understand how busy overall the environment is. So when you see red blobs, it means there are more disks busy at that utilization level. So the utilization is the y-axis here. So case in point, you can see here that the red line is around about the 20% busy. And then you've got this yellow fuzz around that. So you can see that what you don't want to see is that red and yellow area moving up that chart, because that would indicate the bulk of your OSDs are running at that utilization level. So that's what that heat map's all about. And then beyond that, we've got your normal sort of suspects. We have disk latency, disk utilization, IOPS per disk, and throughput. So we've got a pull down as well at the top. So if we were looking and we wanted to look at Servo 2, then here's Servo 2. It's contributing 3 terabytes of the 11 drives. There's its heat map. And say we saw something a bit squiffy with the latencies. So we can see here that write latencies are really where it's high as opposed to reads. And so this is where the hierarchy of dish maps of dashboards come in. So we can jump across into latency by server. So now we can see all of the hosts by latency in the top chart. So pretty much it's doing quite well actually. Pretty rounded out. It's all the same sort of evenness. But carrying on with the story of we suspect something wrong with SRVO2, then okay, we can see that its max latency is here. So have we got some disk which is contributing to that? So can we go further? Yes, we can. So now we can drill down into OSD node detail for that particular server. So now we can see all of the disks that are available on that host by their OSD as well, what the device class is, how big it is, what physical spindle it is, and what Ceph version it is up front, and then what those charts look like for that particular host, in terms of disk utilization, IOPS, latency, and throughput. And if we thought, okay, well, there's a particular disk that we're worried about, maybe it's G, right? So let's select G. So G is OSD 91. and we've got the stats out now for OSD 91. And also to round it all off, we've got for that particular host a view of its CPU and its network load. So we can see whether we're network congested or not, or whether we're CPU throttled or not, as is the case here. So that's what I mean by the hierarchy of dashboards. You can start in one place and drill down to the physical spindle and relate it back to the OSD that's in question. Right, let's go back to at a glance. And then the final one is a network. So no surprises here. We're using the node exporter, so we've got access to the network stats. So here's the cluster load as a whole, and then we break it down into the OSD hosts and the cluster, mons. So we can see here that we have a couple of hosts which are running with a higher throughput over the network. Why is that? By design. So in this particular environment, the RGW, the Rados gateways, are actually running co-located on a couple of OSD hosts as well. So that's why they're higher. So it's that traffic that's contributing to that. So that's how we sort of show network. And then we can see on the right hand side we have active alerts. So out of the box, cephmetrics comes with a number of pre-configured triggers or alerts. So here's what you get. We get an overall Ceph health. So when you transition from OK to warn, or from warn to error, then you get an alert. What we do is we set up a notifications channel called cephmetrics, which basically goes nowhere. So once you've installed it, because every environment could be different, you just need to configure what that notification channel means. So does it go to PagerDuty? Does it go to Sensu? Does it go to email? Or whatever. We'll have to leave that as an exercise for the user. But these are the out-of-the-box alerts you can see. And you can see that right now I'm triggering on packet drops. So I've got interfaces, because I'm using IP over IB in this environment, which are doing some packet drops for some reason. So there's my problem. So that's it for alert status. And finally, the other thing that we've shown, which isn't quite mainstream, I suppose, in terms of Ceph deployments right now, is Icicle E. So I'm generating Icicle E load. So what we provide for Icicle E. So there's an overview dashboard. Again, this comes with cephmetrics. The RBD target gateway daemon that basically stands up the Icicle E target on the gateway nodes has an embedded Prometheus exporter. So Prometheus just scrapes that at these intervals and gives us this information. So we get configuration information as well as performance information. The overview here shows what the config looks like. So we've got 2 gateways, 2 clients, 2 active sessions. I've got 40 gig defined, and I've got 2 LUNs, and I've got unused LUNs. So you may think, what does that mean, unused LUNs? That means there have been some LUNs defined to LAO, but they haven't been masked to any given client or group of clients, host groups. So if that was showing, a number higher than 1 or 2, it could potentially mean that you've got rogue LUNs that are just sat there, potentially consuming space if they've been reclaimed and actually hold data that have been forgotten about. So that's kind of nice to keep an eye on. And then we've got performance stats like IOPS and throughput, and then network load by gateway, so we can see where that load is being generated. And if we drill down a bit further, we can see each one of those gateways where that load is. So for this particular one, we can see that the bulk of all the I/O is basically hitting one gateway. So I've got a multipathing issue on my clients, or on one of the clients anyway, because it's not sending it where it should be. And we've got throughput by gateway, and obviously with IOPS and throughput, when you go through a gateway, there is a price to pay, and that price to pay is in CPU. So we can see and track CPU growth. So you can match up what your IOPS throughput is against your CPU busy on a particular gateway. So that's the gateway view of the world. And then we've got a breakdown at a high level of the clients. So every client will appear on here. and show you how busy those particular clients are in terms of IOPS and throughput by client. So in this case, I've got two clients running, FIO1 and FIO2, and they both are doing the same workload, which is why their lines are pretty much tracking. If you wanted more information about clients, then you can either click on the clients panel, or you can go to the right-hand side, which is where we've got the little menu selection, and click Icicle E client details. Now we can dive into the specifics for that particular client. So FIO1 is visible, and we can see which disk FIO1 is driving I/O against. So if you've got 10 disks, you're going to have this as a stack chart, so you can see contributions to the overall IOPS per RBD image. And then same thing goes for throughput. So you've got read-write against each of those images also shown within FIO1. And we can see in this final table that RBD disk 01, which is that disk image, it's actually owned in terms of the primary path through this particular gateway, and it's 20 gig in size. And you can just select a different client to see its stats show up. Okay. So that is the Icicle E side of things. Let's go back to at a glance. Okay, so that gives you a view of what cephmetrics is all about, what kind of metrics are exposed, how it brings together operating system with Ceph to give you more of an end-to-end monitoring solution, and also how it can help with alerting. So hopefully it's been helpful. Give it a go if you've got time. Enjoy.